what are the typical access times which are existing for various devices? Well, the term which is onto the top happens to be static RAM. I think you must be aware about this particular term. We call it cache in most of the computer systems. The second term is the dynamic RAM, which once again is the main memory of any computer system. Then we have EEPROM and read-only memory. Let us look into typical cycle times. 5 to 15 nanoseconds for static RAM. It is very close to what you are going to find the cycle times for a particular processor is if you convert your required megahertz and gigahertz into the necessary cycle times. For dynamic RAMs, they are of the vicinity of 50 to 70 nanoseconds. You can see that it is almost 5 to 6 times faster than your cache memory, and that basically explains why do you need cache in any system. Okay. Third and the fourth happens to be EEPROM and read-only memory, which are onto the higher side once again. However, these memories are kept intentionally like that, reason being that these memories are to be utilized probably once only at the time of when the execution begins. Some of the newer processors, what they do, they call the concept called shadowing. What they do, they read the content given in ROMs, EEPROMs. Once they have read those contents, then they move it to RAMs. Reason being, the EEPROMs and ROM technologies, considering the cost constraints, we fabricate as very low access time, very high access time RAM memory, and therefore if we move it into the RAM, overall performance of the system is going to be on the higher side. So keeping all these things into consideration, the performance criteria and the performance related stuff for memory to processor is normally designed in any computer system. But does memory cycle time gives us a true measure of processor performance? Well, probably not. In that particular case, what I would like to define is the term memory cycle time. After all, what is the reason why memory, that is the memory access time, does not give us the proper measure? Well, there are certain memories, especially of the type DRAMs, which has the tendency to give some time after a read-write operation has been performed. That time may be given for refreshing the circuits or maybe for some other electronic requirement of a particular memory. But in many memories, this is the requirement. If such is the requirement, then obviously you are not looking at the true measure of the performance of the computer. So or in fact in this particular case, the memory. So what you are looking at is something which gives you the true measure, and that happens to be the memory cycle time. However, in most cases you will find in most memories only the access time is defined to be the real kind of order. Actually that is what is defined for most of the cases and not the cycle time. Well, are these two measures, that is the memory and for the processor, are these two performance terms sufficient for defining the performance of the computer? Well, as I indicated earlier, probably not. We need one additional terminology also, and that is for the bus. So how the performance of a bus is defined? Well, the performance of bus is defined to be two basic terminology I have given in the slide. The first one happens to be the bus width, the size of the bus. The second one happens to be the clock speed of the bus. At what speed, at what clock synchronization speed the bus can operate. And third one happens to be In fact, these are the only two terms. I have not defined the third one. Third one is just an example. Look into the example which I have given in the slide. The width of PCI bus is 64 bits. However, in most of the processor, we use only 32 bits. That is the last point. PCI may be implemented as 32-bit bus. Reasons: the technology is not sufficiently equipped to handle that kind of data transfer. The second point which I have mentioned in the slide happens to be the clock speed, and the PCI have 33 or 66 or even 100 megahertz in some newer configurations. So this kind of a performance you can expect in the PCI kind of environment. But is it sufficient to cater for the required nanosecond speed which you require from to the processor and to the memory? Probably yes. Because the third term which we define in the case of bus happens to be throughput, and that is what is the major controlling factor for the performance of the bus. The throughput is defined to be the amount of data transferred from one place to another. Typically, throughputs are measured in kbps and mbps, and the PCI bus for which we were giving the example is with the 32 bits, suppose it is implemented as 32 bits and 33 megahertz bus, then it yields a throughput rate of 133 megabyte per second in this particular case. You can compare, I think 32 divided by 8, which gives us 4 byte, into 33 gives us around 133 megabyte per second. So you can imagine that this much transfer rate can be sustained by the bus which is of 33 megahertz. Think of a situation when it is 100 megahertz. So this kind of a bus is sufficient to cater for the need of our Pentium 3 450 megahertz. Onto the other side, memory having the clock cycle, or the cache memory having a clock cycle, in fact not the, that is the cycle time of around 5 to 15 nanoseconds. So these three measures basically specifies the internal processing of any computer system. But what happens when data is to be outputted and inputted in the form of files when a program is getting executed? Obviously you require some more processing terms or performance terms which will be valid for the case of when we are dealing with overall computer system. Well, those performance measures are for the storage devices. We cannot define performance measures for the input-output such as keyboard and all those kinds of things which are dependent on the user. But we can definitely define these kinds of terminology in the cases of storage devices. And for the storage devices, the two terms which are there happens to be the access time and data transfer rate. These are the two important measures for any secondary storage devices. Well, how do we define access time in the case of secondary storage devices? Well, I would like to define the access time for disk. For all other devices, it may be more. The access time for the disk is defined to be seek time, that is the time taken to position a head. Okay, now let me define it using this particular disk. Although it is a CD, yet we are using it for the definition of defining seek time. Assume that this particular thing which I am holding in my hand, it is just a pen holder, this is a head and this is my disk. In that particular case, seek time happens to be the time of moment of disk is rotating. See, the disk has to rotate. whereas this particular head will be moving from whatever track. The track can be here, at this surface, okay, I think I'll take this particular surface. Track may be at this point, that point, at all these may be forming tracks which are very close to each other, and head will be moving onto these tracks. Okay, so that is how we define seek time. Obviously, the seek time is going to be onto the higher side for any disk. The second happens to be rotational delay. We call it rotational latency, which is the time taken by a sector to reach under the head while it is rotating. Take this particular example. Suppose this particular disk is rotating and it is rotating very fast. Okay, it will take, suppose this is the sector I am interested in where the blue is starting and it has passed the head. Now time taken to come back that particular sector below the head, which is, let's say, this particular finger, is going to be substantial. If you compare it, this kinds of time, if you try to compare it to the processor technology, you will find there is a gap of around 1000 or times. Roughly this gap is of 1000 times from the processor time, which is of a very, very high figure. The access time which I am trying to define are also shown in the slide. That is, hard disk drive show an access time of 6 to 12 milliseconds, and that consists of both seek and latency. Erasable optical disks are showing even higher time, which is on the vicinity of 19 to 100 milliseconds. CD-ROMs are showing of the type 80 to 800 milliseconds. Even though these times are almost 200 to 1000 times higher than the memory cycle time, yet we cannot ignore the importance of these kinds of technologies. After all, these are the technologies which are providing us permanence in storage, and that too tremendous capacity, infinite capacity. Therefore, these technologies are important for any computer system. However, for the overall performance of the computer system, these technologies, especially the magnetic disk, which happens to be the online storage device for any computer system, the performance for that we require onto the higher side. Okay. The second performance criteria which goes with any hard disk happens to be data transfer rate. The data transfer rate is defined to be the speed with which data can be transmitted from one storage device through the interface such as UDMA to system. Well, what is UDMA? Well, UDMA we have already defined in the previous session, and it is ultra, okay, DMA, direct memory access. This is a new protocol or new technology which supports a very high data transfer rate from the hard disk or secondary storage device technology to the memory unit through processor or without processor. That really depends on the concept called direct memory access, what kind of access is being desired. Once we are saying DMA, it simply means direct memory access. That means the processor intervention will be required to a very least extent. The second point mentioned in the slide happens to be data rates are often measured in megabits or megabytes per second. One measure I have already shown to you. And third, there is another term which is associated with it, happens to be throughput. And throughput basically we have defined for bus and other kind of system. So in overall, all these configuration term, all these performance term put together may define the system. However, are they defining the true measure of the particular system? Probably not. We may say, okay, if I am having, let's say, 400 megahertz processor or 450 megahertz processor, then I need a 100 megahertz bus which is fabricated on my motherboard. I need a very high amount of cache, 512 onboard cache which is available, let's say L1, L2 cache. Okay, so these kinds of cache memories I require in my particular processor, and I require, since my particular device is going to be used in a very highly input-output intensive kind of operation, such as it may be a server, then it requires UDMA or even higher megabits per second kind of data transfer rate. So for a general computer system, we may define these kinds of terminology. Yet, all these things in some sense are to be synchronized. Only then your computer system is going to perform in an idealistic, high performance oriented fashion. So how do we measure the overall performance of a system? Well, there is no true measures of that particular kind existing. Probably whenever no such measure is existing, then we fall back to our software measures. Okay, and that we call benchmark kind of testing. So what is a benchmark? Benchmark is a test used to compare performance of hardware and or software. Second point is, a benchmark may test graphic speed. One of the things is, suppose your processor is doing some graphics kind of calculation. You want to use it for graphics computation. You want to buy a computer which is extremely good for graphics computation. You want a benchmark which can test it. You want to see your processor or your hardware is Y2K compliant. There is a benchmark existing for it. You can run that. You want to check the performance of floating point, and you want to check the performance of integer unit. There are benchmarks existing for it. But where are they existing? Is there any place where these benchmarks exist? Well, I'll give you one organization which is also available onto the internet, and they are in the process of development of benchmarks. You have to be careful as far as benchmarks are concerned. Reason being, different companies may evolve their own benchmarks and may tell you that this kind of performance is best for my computer, and this my computer is showing very good performance in these kinds of conditions, and that second computer is not doing so. So you have to be careful what kind of benchmark they are evolving. Probably we have to do a standard benchmark testing. Where are those benchmark tests available? Well, those are available at place SPEC. Okay, that is Standard Performance Evaluation Corporation, which is a non-profit corporation set up by many computer and microprocessor vendors, and the basic objective is to create standard set of benchmark tests. You can approach this particular people. They are available onto the net. I have not given you the site address. You have to search it onto the internet. And the most widely used tests which have been created by this SPEC people happens to be SPEC 95, or which we call more popularly known as CPU 95 test. This particular test basically tests the integer operation of a particular CPU, as well as it tests the floating point operations of a particular CPU. So with this, we come to the closing of this particular session. What we have discussed in this particular session is the basic performance terminology for various processors, memory, the input-output, that is the storage technology in that, and the bus. And in addition, I have tried to give you the importance of having benchmark in any computer, or using benchmark for any computer system. With this, I would like to say bye to you. Bye for now. See you.